So I will begin my talk. The talk title is AIBench Methodology, Benchmarking Challenging Methodology and Progress. This is my email. If you have any question, you can contact me. Use this email or just use Gmail. This is the website of Bench Council organization. So let's begin. This AIBench contributor, I think more than 30 companies or institutes have contributed to AIBench. So first, in the first slides, I will talk about the AI benchmarking challenging. I think the first one is prohibitive cost. I think because some optimization improve the throughput, but finally hurt the model quality, because we care not only about the performance, but also about the model quality. So running an entire training session is mandatory. An entire training session means we have to train the AI task to achieve the state-of-the-art model quality. So it's basically, it will take several weeks to run a complete training session on a small-scale system. Of course, our architecture community usually use simulator. It have slowed down from time to 1,000 times. Of course, and we exaggerate the challenging. Someone maybe just wonder why not use a micro benchmark. But a micro benchmark like HPC AI cannot model the learning dynamic of deep learning. Maybe you can know about more detail from this website. So the second challenge is the conflicting requirement in different stages. Overall, we know we cannot run component benchmark because it is so hard. It cannot run on a simulator. Micro benchmark are indeed affordable, but cannot model learning dynamic. Of course, at different stages, we have different accounts. For example, for early stage evaluation, we care about the benchmark should be affordable, portable, and simplicity. But at a later stage, for the proposal evaluation or purchasing of the self-system, we hope the benchmark are comprehensive and predictive. We care about the overall system performance in reality. So I think the third challenge is short shelf-life. This because AI model evolution change outpaces the AI benchmark. For example, it often takes more than 1 year to work through benchmark design, implementation, community adoption, and large-scale testing. But after 1 year later, the model is not state-of-the-art because the machine learning or deep learning community will propose a new model. So it may be that the benchmark is out of, is not used again. So of course, someone maybe why not use synthetic benchmark like ParDNN? It indeed can trap the many network, but it cannot model learning dynamics. The fourth challenge is scalability. I think, for example, if you just run a benchmark like impact to evaluate a supercomputer, we can easily to change the problem scale. But for AI task, the problem scale is not scalable. Actually is fixed. For example, this picture is from HPC AI 500 ranking. We can see running image classification, it often takes 1.2 minutes. You can finish the task. It cannot stress testing system. Of course, this number is updated very fastly. I know that most of the recent data is only 20 seconds for training or image data classification model on a supercomputer. The fifth challenge is repeatability. The benchmark, because benchmark is a measurement tool, it have to be repeatable. However, training deep network is stochastic. For example, there are many factors contribute to the randomness. For example, mode annotation, data argument, data source, or dropout. For example, from this figure, we can see this figure reports run-to-run variation of AIBench training. We can see when we measure the run-to-run variation, the largest number is more than 35% for 3D face recognition. These workloads are all these workloads are from AIBench training. Of course, for image classification, for learning to rank, the variation is very low. But on the average, the variation is very large. So this is another example. The epoch to achieve type quality very significantly, even widely on the different running sets. We just run image to text from AIBench training 4 times using different running sets. You can learn about more detail from this paper. This paper is accepted by the PAS 2021. So we have talked about the challenges. Then I will give some very short summary about the latest work. I think AI benchmarking many work. For example, at ISRAP 2016, that's a fashion. It includes 8 workloads, include training and inference, but it provided no quality metric. Then the later is DA mark. It published at GPU 2017. It provided 8 micro benchmark. DeepBench is from Baidu. They also only provide basic operator. It's about the micro benchmark. Then Bench IP also provide a micro benchmark and some very simple, very shadow neural network model. DownBench is the first work proposed using time to accuracy as a metric. TPD3 is published at ISRAP 2008. It provides 8 workload. Then this is our work AIBench. We highlighted in blue. Published by G18, ISRAP 18, PACT 18, and ISPAS 21. For the proposed scenario benchmark, I will talk about what scenario benchmark later. It includes 19 tasks, 19 workloads. Also provided several subsets. Of course, another concurrent work is MLPerf. It provides 7 workloads. It also another AINA-DNN is another benchmark suite. Regarding HPC AI benchmarking, someone also just use for AI for science. It have the first one in DownBench. Then our work HPC AI 500 is published at Bench 18. We provide 3 representative application of scientific deep learning. I think the difference is that we provide real-world scientific deep learning. We also propose a valid flops as a metric. Then another benchmark is Deep 500. It only provides framework. I think it has no concrete reference implementation. HPAI is from Professor Jake Dangra, but it's only micro benchmark. I just mentioned AI micro benchmark is affordable, but it cannot model learning dynamic. Another work is MLPerf. I think MLPerf constantly also provide the HPC for AI check. Interestingly, I find for HPC AI check, MLPerf share several workloads, just same workload from HPC AI 500. AIBench use only 1 workload based on AutoML. I think the workload is scalable because for AutoML you can increase the problem scale, but it cannot hard to ensure repeatability. Just I report the randomness in the slides before. Another one is SciMFL. This is from Roosevelt Laboratory at United Kingdom. Lead scientist is Professor Tony Hay. The target of this benchmark is benchmark AI for science, including material, life, and earth science, particle physics, and astronomy. AI benchmark for edge computing, I think one is Edge AIBench. This is also from our group. Later I will talk about we introduce that relationship among our benchmark. AIBench is published at UCC. Another Edge AI benchmarking is EMBC MLmark. AI benchmark for IoT, I think the first one is ETH AI benchmark. And current work is AIBench, is also from our group. This is a very simple summary of a concurrent AI benchmark project. I think I give a very short summary of related work. I think Bench is the first benchmark that proposed time to accuracy as a primary metric. AIBench is the first benchmark modeling the creative path of real-world application scenario. DNA is the first synthetic AI benchmark. HPC AI is a micro benchmark using mixed processing AU decomposition to achieve outbound float problems. But AU decomposition is not relevant to most of AI workload. I think both ParaDN and HPC AI cannot model learning dynamic and also fail to consider the model quality. I also want to compare AIBench and MLPerf. I think this is two systematic AI benchmark projects. They are concurrent and complementary. AIBench suite are by far the most comprehensive AI benchmark suite tackling challenges 1 to 5. More detail you can find from our ISPAS 2021 paper. I think just I at the beginning I summarized the 5 challenges. First challenge is the prohibitive cost. The second challenge is the conflicting requirement at different stage. Third challenge is short self-life and the fast evolution of AI model. Fourth challenge is scalability challenge due to the fixed problem scale. The fifth challenge is repeatability challenge due to the stochastic AI. MLPerf includes 7 benchmarks for training and 5 benchmarks for inference. MLPerf performs the most large-scale testing. I think it failed to provide the benchmark methodology to justify the choice for an updated AI model, task model they set. MLPerf failed to consider the conflicting requirement, self-life, scalable challenging. Also, of course, I think all concurrent work are ongoing work. They will update very frequently. So for the third part, I want to talk about AIBench methodology. First, I want to introduce AIBench Council. AIBench Council is an international open benchmark council. The website is this one. It's a non-profit international organization aimed at promoting standardizing and incubating big data AI chip and other emerging technology. This is the AIBench homepage. Currently, AIBench provides a very comprehensive AI benchmark. First is scenario benchmark. I think this is just a model that created parts of real-world application scenario. We have two sets. Is AIBench scenario. It is more than most of internet service application. The second one is Edge AIBench. It is more the interaction between IoT edge and the data center. I think certain part we provide training. AIBench training is include a training workload. Meanwhile, it provide AIBench subset because we provide 19 training workload. It's very, I think it's very. You have to spend a lot of time to testing all these workloads. So we provide a subset, provide AIBench subset. Meanwhile, we provide HPC AI 500 is for test the super HPC AI computer system. Then also provide inference. Inference because inference workload is very lightweight because you can run an inference workload in several minutes. So we provide very comprehensive AIBench inference. We also provide AIBench is a lightweight implementation of AIBench inference. Meanwhile, we also provide micro benchmark because the reason is very simple. Because for architecture community, we cannot run component benchmark or scenario benchmark on simulator. So we also provide a micro benchmark. Meanwhile, also provide a synthetic benchmark because our model, our AI model update very fast. Machine learning, deep learning community we propose many state of model. Our benchmarking, you have spent at least 1 year to work through the benchmark design, implementation, and promotion. So it will, you have to use some synthetic benchmark. For this case, you can test the different case. So first, I want to introduce AIBench methodology. So as a joint work with increasing industry partner, AIBench is a comprehensive AI benchmark project focused on methodology, framework, and continuous improvement, tackle challenging 1 to 5 method ball in a systematic manner. First, the AIBench scenario model the creative path for real-world application scenario. For example, for search engine, for social network, for electronic commands, I think they are all of them are real-world application scenario. So we model the creative path of real-world application scenario as a permutation of the AI and the non-AI module. Someone maybe just care about AI, but AI component have to work in a real scenario, maybe just a very small part. So the second is Edge AIBench. Edge AIBench is instance of a scenario benchmark suite, modeling end-to-end performance across IoT edge in the data center. Because for edge computing, there are many components deployed at a different layer, collaborate to achieve a target. So I think they are also scenario benchmark. The second part is AIBench training and AIBench inference. AIBench training and AIBench inference cover 90 repetitive AI tasks we update with state-of-the-art model to guarantee diversity and representativeness. AIBench training provided two subsets for repeatable performance ranking. I just emphasize repeatable because for performance ranking, you have to guarantee that number is repeatable. You cannot have very high variation. Meanwhile, we also provide workload variation. As I mentioned earlier, there are many workload is variation very high in terms of the epoch to achieve the target quality. So, but these workload are also very important for design input for AI accelerate. So we also provide workload variation subset to improve. So meanwhile, I also provide AI 500 to evaluate a large-scale HPC AI system. Someone maybe use another term, for example, AI for science. HPC AI 500 is derived from AIBench training repeatable performance ranking subset to evaluate various IoT and embedded device. AIoT bench derived from AIBench inference. Meanwhile, as architecture community cannot use component or synthetic or scenario benchmark and simulator. So we also provide intensively use the hotspot function provided from AIBench training inference for simulation-based architecture research. As a complementary to real-world benchmark, AIBench synthetic will provide several synthetic benchmark with scalable problem size. I just mentioned that most AI tasks are the problem scale is fixed. But if you want to evaluate a large scale system, you have to provide a scalable problem scale. So we can provide a scalable problem size that can model learning dynamic. So let's first introduce AIBench scenario. First, someone maybe just ask, is micro benchmark sufficient? Of course, AI workload need to consider both computational efficiency and model quality. Flops is no longer the only metric. For example, we just take into account mixed precision. Mixed precision training significantly improve flop. For example, this line is, I think this is, this line is for mixed precision. Blue line is for floating point 32. We can see mixed precision indeed improves the super performance, but it holds the target quality. For example, you can see when the node size increases from 1 node to 8 node, the target quality drop very large. Another reason for we cannot use micro benchmark because there's no single kernel. For example, we profile the 70 AI workload from AIBench. We found that there are many micro benchmark. Some micro benchmark only occupy a little %. Someone may just ask, is my component benchmark sufficient? From this example, I will show why component benchmark is not sufficient. For example, we just benchmark with a single component, image to text. When we use the OCR model pruning, this is the optimization technique. We can find take latency shortened by 51%. I think it is a very large improvement. But accuracy decreased 1%. But you put this optimization into in a scenario benchmark from AIBench. Online translation intelligence, it includes several components, of course include image to text. We can find that the tail latency has no improvement, but the accuracy decreased by 1%. Of course, we cannot accept this result. So that if you use component benchmark or use scenario benchmark, you can draw inconsistent conclusion. If you want to know about more detail, you can read out this paper. Meanwhile, we can compare single component with a related application. We just use another scenario benchmark from AIBench. We can find the overall system tail latency deteriorated over even 100 times compared to a single component tail latency. If you just compare with the recommendation component, the gap is 2.2 times. But if we compare to text clarification component, the gap is high as 180. So you cannot randomly choose a component benchmark. You have to put that in the real scenario. Meanwhile, we have to trade off model accuracy versus quality of service. For example, for electronic command search intelligence, another scenario benchmark from AIBench. If you replace ZSNet 50 with ZSNet 152 for image clarification, you can find model accuracy improved by 1.5%, but overall system 99% latency deteriorated by 90.7 times. So we cannot accept this optimization. So benchmark with a single component cannot reflect the trade-off between the model accuracy and quality of service. So of course, someone maybe we can use a statistical model. For example, maybe some just think a static model can predict the overall system tail latency through providing many component tail latency are perfect. Our answer is no. For example, we just use simple queuing model. The gap is very large. But of course, someone maybe just you can use a sophisticated queuing network. But it is difficult for tail latency prediction because it has a non-superposition property. So a bench scenario is indeed. If you want to know about more detail, you can visit this web page. It's a process of related application scenario because the Z1 is treated as a first-class confidential issue. We have singled 9 scenario benchmark in cooperation with many industry partners. Because the reason for it, would like to work with us because they think process benchmark can bridge the gap between industry and academia. We can try different optimization on process benchmark. Of course, they will not disclose the confidential issue. So that scenario benchmark can capture the creative path and provide primary module. It is the permutation of a series of AI and non-AI components. For example, I give 2 examples. Because of time limited, we want to spend too many time to elaborate on the scenario benchmark. Basically, it provides several modules. For example, it includes a query generated online module, offline module, and a data storage module. We all provide we all open source the source code. If you finish it, you just can visit our web page. You can download try our code. Our second one is online translation intelligence. I think basic conclusion is that scenario benchmark is very complex with respect to a simple component benchmark. So I will talk about Edge AI Bench. I just mentioned earlier, Edge AI Bench is an instance of a scenario benchmark suite. It model end-to-end performance across IoT edge data center. Because in my opinion, we only need to propose a specification for workload. We can provide a different implementation. For example, we can deploy one component at IoT or even edge or data center. You can provide a different interaction strategy. So you can visit our paper, read our paper to know about more detail. Currently, we have included 4 scenarios. First one, autonomous vehicle. I think for this scenario, you must guarantee the accuracy very high because it's mission critical. Meanwhile, it must be latency sensitive. Of course, all vehicles are moving, so it devices mobility. Second scenario is ICU patient monitor. Of course, it's also latency sensitive. For example, you have to respond to the millisecond. But with respect to autonomic vehicle, it can tolerate some error. For example, the ICU patient monitor maybe provide many warnings which are not urgent, but we can just ignore this error. Meanwhile, they are parallel because there are many massive patients to be monitored. The third one is surveillance camera. I think it provides many data size very large. Fourth is smart home. It includes a heterogeneous device and data. Currently, we have provided 9 typical AI tasks for 4 scenarios. It provides different model, different data set, and different implementation. I think you can download all this source code or just read our paper, give a very short summary of our paper. Of course, I just, for my tutorial, I just give a summary of all the AIBench benchmark suite. Later, I think we have later 5 or 6 talk will give more detail about each work. Then I will talk about AIBench training. I just mentioned earlier, for AIBench training, we consider conflicting benchmark requirement. For example, at early stage evaluation for new architectural system, it have to be more portability. So we also provide a micro benchmark. Meanwhile, we provide a subset. For subset, for example, currently we have the training, AIBench training provide 19 workload, but we provide a subset considering only 2 or 3 workload. So you have to give a very quick evaluation. Also, we provide a lazy stage evaluation. You can run comprehensive workload, even you can run each workload from AIBench training. Of course, we consider diverse behavior for workload evaluation. For example, micro level, we consider flow of the memory access pattern, computing pattern, and I/O pattern. For system level, we consider time to quality metric, run-to-run variation in terms of ratio of standard deviation to the mean of epoch to quality. We consider convergence rate. It's about the epoch to quality. Of course, the quality maybe is different from the state of the quality, because when you train a workload, maybe you will meet several convergence. Also, we consider number of host function. Later, we consider the average algorithm level. We consider model architecture and parameter. So currently, we have provided 19 workloads. For example, for text processing, we provide 7 workloads. For image processing, we provide 8 workloads. For audio processing, we provide 1 workload. Video processing, we provide 1. Someone maybe just, why you propose so many workloads? I think because different workloads have different workload calculation. Later we will cluster all this workload to include several sub-clusters. For each sub-cluster, we will find one representative workload. For example, take electronic commands as example. We can find for different, for example, for search, it is related to several component benchmark, for example, image classification, object detection, spatial transformer, translation, and speech recognition. So that's the real world application are very complex. Okay. We also consider the plenty with, for example, in this table, we compare AIBench training version 1.1 versus improve training versus 0.7. Of course, we will, both of us will update the model and the workload. This is the current state. For AIBench subset, we consider two different properties. For example, performance ranking, we need to consider fairness. You cannot randomly choose workload, just use it to compare ranking different performance of different systems. We also consider low cost. We cannot run 19 or 20 workload. Meanwhile, we also consider workload curation. For example, the preventiveness, comprehensiveness, and the diversity. I think for AI, we also consider another factor. For example, for GPU, because it's very, actually GPU is general purpose. It's very easy to portable a new workload on GPU. But for some workload, its performance maybe not maybe it cannot achieve the high performance, but it's very easily portable because it have very mature software ecosystem. But for some AI accelerator, for some workload, it can achieve the best performance or even 10 times or sort of that of GPU. But for some for other workload, it cannot even run the workload. Consider that for AI community, for deep learning community, our guys will often propose a new model. Of course, this new model are very difficult for supported on the many AI accelerate. So that's also the reason for why we need to consider the fairness. So this is a current state of two subsets for affordability. For example, for repeatable performance ranking, we have a single 3 workload: image classification, object detection, and learning to rank. Basically, each one from the one cluster. Sorry, you cannot see my. Okay. You can find, for example, learning to rank is from this cluster. Meanwhile, for subset for workload curation, we've singled another 3 workload. I think the reason is different between the two subsets is one fact is that for repeatable performance ranking, you have to consider repeatability. So we remove out the workloads that have very poor repeatability. So I'll talk about HPC AI 500. The criteria for choosing the workload, we consider the preventiveness, affordability, repeatability, computation complexity, task model, dataset, and scalability. So basically, we choose the workload from the repeatable performance ranking subset because AIBench repeatable performance ranking subset satisfies repeatability, the preventiveness, and affordability. Of course, because we are regularly update AIBench training workload. Accordingly, we also have to update the AIBench repeatable performance ranking, and hence HPC AI 500. Currently, we have single image classification and object detection. The reason for we remove learning to rank because its computation complexity is very low. So for HPC AI 500, we have included 2 problem domains. First one is the extreme weather analysis. The data set is from the extreme weather analysis. Another one is image classification. So we have 2 more, fast RCN and resonant FT. For AIBench inference, we consider comprehensive inference workload. I think the reason is very simple because comprehensive workload are not a burden. Inference time is very much short. Even you can run in several minutes or even seconds. So we include diversity of data type, AI model, and AI framework. We also consider diversity of workload behavior. Currently, we have included 19 AIBench inference. I think our team member will talk about provide more detail about AIBench inference. AIoT bench AIBench is aimed to evaluate the AI model framework and hardware on mobile and embedded environment. We provide an out-of-box benchmark because I think most vendor cannot provide, cannot optimize different layer of AI system. It's better for third-party user. I think because the optimization at a different layer is the cost is very heavy. I think for most third-party user cannot afford that cost. So we provide out-of-box benchmark. Meanwhile, we make a comprehensive and apple-to-apple comparison of the algorithm, software, and hardware. AIBench covers the plenty with diverse model framework. It has 16 off-the-shelf workload instances in total. For example, model we provide Resonant 15 in 7 v3, DenseNet 1-to-1, SqueezeNet, MobileNet v2, MNSNet. We provide 3 different frameworks because we find that different frameworks have different problems, even for the same model. We provide TensorFlow-Lite, KF2, PyTorch Mobile. For each model in TensorFlow-Lite, we also provide 3 continuation versions. For example, dynamic range continuation, 4 integer continuation, float 16 continuation. We also consider CPU and API delegate. From this slide, we can find a different operation have different proportion of process time in different model. The x-axis is for different model. We can see for different, for example, FC is short for fully connection. You have different proportion of processing. Also, we found that even for the same operator, for example, for convolution, have diverse distribution of processing time in different model. I think Chenji law will talk about more detail. Meanwhile, I also find the framework diversity. The same model have different problems on different framework. For example, for ResNet 15, the time per image, I think the performance is very widely from different framework. So this slide we provide a micro benchmark. Micro benchmark mainly provided for architecture community. We provide a primitive AI operator and a widely used horseback function from AIBench training and AIBench inference. We compare AIBench micro benchmark with deep bench. We can see we provide more micro benchmark. For deep bench, it only include GMM, convolution, RNN, or deals. For AIBench micro benchmark, it have 12 micro benchmark. Last part is about AIBench synthetic. Synthetic benchmark, the aim is to tackle the short shelf life and scalability challenging. We have the consider design space. For example, the primitive building block from AIBench training. For example, provide a fully connect layer, the video block. It also consider depth, width, and input size. Also consider stride and pattern size. We will change the generated model to convergence to reflect the learning dynamic, which paradigm cannot reflect. So I give a short conclusion. AIBench is a comprehensive and ongoing AIBench project focused on methodology, framework, and continued improvement. It is distinct and abstract zero-world application scenario across data center, HPC, IoT, and edge, into the scenario, training, inference, micro, and synthetic benchmark. We update our benchmark frequently on this website. I also have to announce from Bench Council, how Bench 21 is a broader benchmark conference. I think it check the architecture, HPC, database, multi-learning community to submit the benchmark paper. You're welcome to submit the paper. The website is this one. The deadline for full paper is July 30. We also have a new transaction, Bench Council transaction on benchmark standard and evaluation. This new journal, Professor Tony Hay and me join as the editor-in-chief. We emphasize that further check publication for some paper with have a potential very high impact. We will make a final decision within 2 weeks, so that it will be very fast check publication. Meanwhile, AIBench also have a Bench Council Award. Especially, we have a Bench Council Distinguished Doctor Dissertation Award. If you choose you can please visit the web page. You can contact the award student committee chair. The leader chair is Professor Jack Dangra. You can know about more detail. So this is under my tutorial.